Generally, we use CRO, cathode ray oscilloscopy, to measure the action potential. So by the help of CRO, we will measure the action potential and we will understand the graph. So the graph of action potential, where time is taken as the x-axis and the y-axis referred to the membrane potential of the cell. So at rest, generally the membrane potential is minus 70 millivolt, which is called resting membrane potential. We all know that. In that now in that A point, we will apply stimulus. So for that stimulus, sodium channels start to open, but there is a delay of sodium channel opening. This delay is called latent period. So after that, starting of the sodium influx, and up to C point, there is gradual change of the membrane potential because of the initiation of sodium influx. C point is called threshold potential, or this is also called is firing potential. So after the C point, why it is called firing potential? Because after the C point, the cell is fired. How? Because the sodium channels, number of opening sodium channels are increased, so the sodium influx is increased, so the depolarization start. So up to the D point, the depolarization occur, but then the sodium channels became inactive, so the potassium channel starts to open. So there is a potassium efflux, so rapid repolarization, so the graph goes down, and up to E there is a rapid repolarization. Then the repolarization became slow, so slowly repolarized up to F. But then because of the, so we all know that sodium channels act very fast, so depolarization is very fast, but potassium channels opens a way longer than sodium channels. So potassium channels still open after this point, after point F. So more potassium efflux. For that the membrane potential, the negativity of membrane potential increased much, so increased much up to point G. So this is called hyperpolarized. So the cell is hyperpolarized, but after the point G, the potassium channels are closed, so the membrane potential is recovered and came back to point H. H is resting membrane potential, minus 70 millivolt. So that is the graph. At last, because of the action potential, this is the action generation of action potential. So we can see that there is a spike. Action potential makes a spike, so the action potential also called spike potential.